Okay, for this example where you're trying to find the radius, I have a completed example so that you can work this one after you look at this. So, same problem. We have rotating gears, and so we have one that's rotating 80, the other one's rotating 50. We know the radius of one, we don't know the radius of the other. So what's important to note is that the arc length for both of these are going to be the same. The arc length is going to be the same. So what we're going to do here to start is we want to convert our angles to radians, and that's very important in finding measurements. Okay, so you have to always convert uh, to radians if you're going to find radius. So we go ahead and multiply 80 by pi over 180 and kind of clean it up a little bit. So that first one, the rotation is 4 pi over 9 radians. The other one was 50 degrees, so once again multiplied by pi over 180, and that simplified into 5 pi over 18 radians. Okay, now where's the connection between these two gears? Well, the arc length is going to be the same for both of them. Okay, so arc length is S, and you can see S right here. So the arc length is equal to theta times radius, and so theta has to be in radians. And so that's what I have right here. Okay, so I figured out the arc length of the small gear, which actually is the same as the arc length of the large gear. So when this one turns, 80 degrees, what's going to happen here is it's going to cause this one to turn um, 50 degrees, but that arc length is going to be the same distance that was over here. Okay. Um, okay, so then to figure out the radius, so we're solving for radius, what I did was I took the formula for arc length and solved for r. So I divided by theta on both sides. So I got that radius is equal to arc length divided by uh, my central angle, theta, okay? And so I know what the arc length is of my large one. I know that it's going to be the same as the arc length of the smaller gear, okay? So that's going to be my arc length right here, okay? And then my angle, I figured that out over here earlier, 5 pi over 18. So I have this ratio right here. Now be very careful if you're putting this in the graphing calculator. It's very important that you use the parentheses, okay? If you're using a different calculator, just be careful how you put it in. You might want to double check that when you put it in, you're coming up with the same result I got here for the example, okay? So you should be able to complete the one up above the same exact way. It's going to be done in the exact same process. Let's look at your other one. It's a very similar example. This one's actually easier, okay? This one will actually be a little bit easier. So once again, what they're doing here is they're telling you the rotation of one, but not the other, and so you're trying to figure that out. Now, typically, you need to convert your degrees to radians. In this particular case, we're basically setting up a ratio. So you don't have to do it in this particular case, okay? But you have to be really careful. That previous problem, if you didn't change the degrees to radians, it would have given you some problems. So looking at this example, so we have two gears are adjusted so that the smaller gear drives the larger one. If the smaller one rotates 225 degrees, through how many degrees will the larger one rotate? Okay, so once again, the relationship they have here between the two gears is that uh, the arc length is going to be the same. The arc length is going to be the same. So what we did here is we found out that the arc length of the first one is radius times my angle, which, like I said, typically you should put as um, you should convert that to radians, but they want our answer in degrees. In this particular case, we're just going to set up a ratio, which should be pretty simple. Okay. Um, and then the arc length 2 is same deal, radius times my central angle. And so this time I don't know it, so I leave it as theta. Now, the two arc lengths are equal. S1 is equal to S2, and that's what I have right here. So I set them equal to each other, divide by 4.8, and that's how I ended up with my angle. And so you see my angle is in degrees. So you have to be a little careful because most of the examples you do need to convert to radians. This one was one of the exceptions. Okay, so looking at this problem, I kind of looked at this one and I can kind of see why this one probably was giving you some trouble. The way that this graph looks is not typically the way we probably would have done it in class or on the videos. They're trying to kind of trick you a little bit. So let me just kind of go over the process for graphing these. So the secant is the inverse of cosine. So what you want to do actually is you want to graph the inverse function. So you want to graph uh, or the reciprocal function. You want to graph cosine 1/2 of x right here. So -4 times cosine of 1/2 x. And so what we're going to do here is I'm going to go ahead and make a little table of this, and we're going to graph it, and then we're going to see which one is the reflection, the reciprocal function to this. Okay, so if you remember on the circle, the way I like to do this is, cosine's going to go 1, 0, -1, 0, back to 1. Now, what you have to plug in for x is you want to plug in something that will make it equal 0, equal pi over 2 pi, and then 3 pi over 2. And so you notice that 1/2 right there is going to kind of start throwing things off a little bit, okay? So let's make a little table here. And then obviously I need to multiply by -4 afterwards. Okay, so the first part's pretty easy. I'm going to plug in 0, because if I plug in 0 times 1/2, I get cosine of 0. Cosine of 0 is 1. But then I have to multiply by -4. So when x is 0, this right here turns into a 1. 1 times -4 is -4. Now on this next one, I don't want to plug in pi over 2 because then it will turn into a pi over 4 and it will actually end up right there on my unit circle, right? So I'm actually going to plug in pi, but what's going to happen is it will turn into pi over 2 because of the 1/2. So I'm going to plug in pi, and what happens is it actually is going to end up right here, which gives me 0. 0 times -4 is 0, right? Now I want to get my result for pi, but if I plug in pi, you can see it gets chopped in half, so I need to plug in 2 pi. And so then it turns into pi, which then gives me a result of -1. -1 times -4 is +4. Okay. Then down here, I want to get 3 over 2, but once again, I have to take that into account. So just remember, you're basically plugging in the reciprocal of this. You're going to plug in twice, right? So I'm going to plug in, instead of 3 pi over 2, I'm going to plug in 6 pi over 2, which is 3 pi, simplified. And so when I plug in 3 pi, it gets cut in half, which turns into this. I get a 0. 0 times -4 is 0. Then on our last one, we'll plug in 4 pi, and then half of 4 pi is 2 pi, which is 1 revolution, which will give me a 1. 1 times -4 is -4. Now, what makes this one challenging, as I kind of mentioned at the beginning, is that they're kind of they're using different parameters, which is fine. It kind of challenges you a little bit more to make sure you kind of understand this. So what we want to realize is that, we're graphing the reciprocal function to where all these values that we just got, we're actually gonna get the reciprocal of these. So let me go ahead and sketch a little graph of this and talk a little bit more about the behavior here. So I'm just going to draw this, and you can see they go back into the negative part a little bit, so I'm going to leave myself a little bit of space. But let's see, 0, then we'll do pi, 2 pi, 3 pi, 4 pi, and then I'll do a negative pi back here that we'll look at in a minute. Okay, so I'm going to go ahead and plot these original points right here. So at 0, I'm at -4, about down here. Then at pi, I'm at 0. Then I'm up here at 4. Then I'm back at 0. And I'm down here at -4. So the way this one looks looks about like this. Okay. Okay. So the reciprocal function, what you're going to do is those high and low points stay where they're at. Okay, so those don't change. So these 3 points right here stay where they're at. Okay, and what you do is you're basically going to go. You're going to do a. You're going to go away from it, and that's going to be your reciprocal function. So this is going to kind of create upward, kind of like this. Okay, and then this is going to kind of create this down here, and same thing down here. Okay, um, now see what's different is about your answer choices is they actually don't include up to 4 pi. They stop right here at 3 pi. Okay, so they cut it off right here. And a good way to figure these out is whenever it's 0, that's where one of your asymptotes are going to be at. So that might help you also on the multiple choice part of aspect of these questions. Okay, so if I were to continue this pattern out, you would see that this would actually go like this with this asymptote right here. And so we can see that this one matches up with D. Okay, so if I were you, I would go ahead and answer this one and then just go ahead and do a similar example just to get some extra practice because these are a little tricky. The good news is obviously you'll when you're taking the exam, you can kind of use some of your notes to help you a little bit. Just remember it's timed, so you only have so much time to take it. But all right, let's do another one. You sent me another one of these. Okay, here's another good one. And once again, what makes this one a little bit more challenging than what I would do is, I mean, it's nice because it's multiple choice, I guess, but you don't really get to pick the graph, like how to design your graph. And so once again, they kind of go into the negative area a little bit, which is fine. It's not really that big of a deal. So let's go ahead and look at this one. So what we want to start by doing is changing this to y equals sine of x minus pi over 4. What's that? Okay. So once again, we're going to look at the unit circle here. So sine goes from 0 to 1, back to 0, then to -1, and then to 0. And once again, we're going to go from 0 to pi over 2 to pi to 3 pi over 2, and then to 2 pi on our last point. Okay, so once again, I'm going to make a table. And so you know what you might want to do. Typically, I always want to start at what x value is going to give me 0, and so on and so on. What you might want to do, since these are multiple choice, and you know this isn't cheating or anything, you might want to just use the values that they have. So you might want to plug in like -3 pi over 4, and we'll plug in negative pi over 4, and then positive pi over 4, and then positive 3 pi over 4, and then what was the last one? 5 pi over 4. Okay, so that might help. Like I said, it's not cheating, it's just making sure you're using the same graphing points that they are, okay? So when we plug this in, when you plug it in for x right here, this will turn into -4 pi over 4, which would turn into negative pi. So that would just mean that you rotate backwards here. That's the same thing right there. That's the same thing as negative pi. It's the same thing as positive pi. It's the same thing as negative pi. Okay, so you get 0. So we'll put a 0 there. Okay, then we're going to plug in negative 4 pi, or negative pi over 4 minus pi over 4. That'll be negative 2 pi. Here, let me show the work here so we make sure you got this. So when you plug it in, this will become negative 2 pi over 4, and then we can simplify that into sine of negative pi over 2. So positive pi over 2, so that'd be a quarter turn backwards because it's negative, and that will end at negative 1 right here. See that? Ends at negative 1. So that'll equal negative 1. Then if you plug in pi over 4, you'll get sine of 0, which is 0. Then if you plug in 3 pi over 4, what will happen, I'm going to write this down again just to make sure. When you plug this in, you're going to subtract 1 off. So that will become 2 pi over 4, which is sine of pi over 2, which should give you a 1. Okay. And then 5 pi over 4, you're going to plug that in, subtract off 1. So that would leave you with sine of 4 pi over 4. 4's cancel out, so you get sine of pi, which would take you to 0. Okay, so then I'll do a little sketch here. And once again, I'm going to use their parameters. So this will be about negative 3 pi over 4, negative pi over 4, positive pi over 4, 3 pi over 4, and then 5 pi over 4. And so I'm going to plot those points. So I'm going to go from 0 to negative 1 to 0 to positive 1. Oh, let me fix that. Okay, my bad. That needs to be right there, and then up here, and then right there. Sorry, I accidentally put a point right there. Okay, so let me go ahead and graph this. So it looks something like this. Okay, now those highs and lows are going to be where the other function is going to be, and you're going to, the reciprocal function, and then you're going to just, shade away from it. And then wherever the middle of the graph, I don't want to say when it's 0, because sometimes these graphs shift up and down. So basically where the center of the graph is right there, where that intersects, that's where your asymptotes are going to be. So that's where your asymptotes are right here. And then you have another one of these kind of bowl-shaped graphs on top right here also. This should go up like this. And so let's see which one this kind of matches with. Looks like it matches with C. Okay. So once again, you might want to go ahead and just answer it and then try a couple more examples, because you can probably pretty much expect to see something like this on the exam. I hope this helps you out.